Okay, so welcome to the third video for 8.4. So let's consider. Let's have theta fixed. Radius r variable. Okay, so what would the graph of this look like? So we've got x and y coordinate axes, or a polar graph, it doesn't really matter. X and y. Let's say I have a fixed angle theta. So theta is fixed. But my radius is variable. So let's have radius r in blue be variable. So it can start at the pole, can get increasingly large, this in this direction, or it can go be increasingly negative. That's not along the same line. See, there we go. Okay, so what I get then is a line. If theta is fixed, remember, if my angle or if my radius is negative, that just means I'm measuring the angle from the negative polar axis or negative x-axis. Well, let's consider something similar. So I get a line, right? So i.e. a line. A line. So I get a line if my angle is fixed. Okay. What happens if radius r is fixed? Radius r fixed. Let's have theta variable. Variable. Okay, so what does a graph of that look like? So theta versus f of theta coordinate axes, or x versus y. I don't know what I'm saying. I'm reverting back to earlier. Okay. So x and y. So now theta is variable, but my radius is fixed. So say my radius is always 4. But I can sweep through any angle. So that means why is this like the world's worst drawing of a circle? Why is it not letting me draw a circle? What is going on? Okay, let's say that this is the circle then. Okay, there we go. I think I did put that point in the wrong spot. Okay, so we've got a fixed radius. So this is my radius, r, but my angle can be anything. So my angle can go wherever it wants. So if my radius is fixed, but my angle theta varies, so it can sweep around and around and around, what do I get? A circle. And what's more, the radius is r. So, theorem. So part 1, if theta is some real number a, this is a line through the pole at an angle theta with respect to the polar axis. That is the x-axis. Similarly, if I have some radius fixed, some number a, real number a, this is a circle. Centered at the pole of radius r, or of radius a, actually, in this case. Okay, so for example, let's plot some of these. So for example, plot the following polar graphs. And I guess I could do this on one set of coordinate axes. So number 1, let's plot r equals to 3, and number 2, let's plot theta is equal to pi over 3. Because I think it makes sense. So let's just do one x and y coordinate axes. Oh shoot, why do I always do that? Okay, let's see if I can draw this a bit better. Don't know what it is. Can never seem to. I guess I really dislike even numbers so much. I can never create an axis that is even. Okay, so we have concentric circles for my polar graph. Well, an attempt at concentric circles. Come on, no, okay, oops. Come on. Okay, 1 concentric circle, 2 concentric circles, 3 concentric circles, 4 concentric circles, just for the heck of it. Okay. Okay, I think that's good enough. And we'll do our 45-degree reference angles, or 60-degree reference angles. Degrees. Oops, that was terrible. What did I do there? What have I done? That was horrible. Okay, let's see. I see what I've done. Okay. Nope. What am I doing? Why is this not working out? I have no idea. Okay. Well, assume that you will, if you will, that this looks okay, which it doesn't, but we get the idea. So here's my polar graph. Okay, so if I have a radius of 3, then I go out you can hear my kitty in the background. So radius of 3 is just simply a circle centered at the origin of radius 3. So this is r equals to 3. And now let's do theta equals to pi over 3. So here's pi over 3 up here at 60 degrees. So my angle is fixed, but my radius can be whatever it wants. So it's a line. So there we are. So that is it for those. And I think I need to stop to deal with my kitty, and I'll see you in the next video.